So last February at the Florida Flywheelers Show, I've seen this laying around. This is a blower attachment for like a weed eater thing, and it had a tube on it like this. Anyways, I got looking at it and I thought, we could make a bubble machine out of that. So I've had this, and then I had a motor, the gearbox, similar to this right here. That's a gearbox, 12 volt DC, and coming up with a way to put it together. And this is what we ended up with. And you can see this is all 3D printed. Got a shaft out here. So this, the idea that I'm having is, we'll go like this. This will be run by a hit and miss engine. I'll have a pulley on here. And then this 3 or 12 volt DC motor will run this and turn the shaft with the holes in it that make the bubbles. So I had to have somebody do that, and Pete, my son Pete, designed this and did it on a 3D printer. So this is my son Pete, and he'll explain how that's done on the computer. This is new technology being used on old technology.
Yeah, so we measured the dimensions of the, started with the blower, so we had to measure it and figure out ways to mount on it. And they had a nice piece on this side over here. So I got those basic measurements of the blower, and I just did a block diagram in there, and then drew some sketches of the different shapes that I needed to build out of, and then I just started building from there. We started with this bracket over here, so I can hide this. So we made a two-part two-piece part on a mount, because you can't 3D print it in that shape, so that's why it has to be two pieces.
Yep.
So you can print flat.
This part and this part are two separate pieces.
Here, so if I hide all the sketches, you can see the two parts right there. So this one printed flat on this side, on that bottom part. That's how it went in the 3D printer. And then this one just printed on, it can print on either side. So we printed two parts and then super glued them together, because plastic super glues together well. And that's the mount that you see right there holding the motor. And then we needed something to stick onto the motor, because then we're going to put a bubble like screen out here to pick up the soap and then pull it in front of the blower.
And then this is also the nut that was made to mount it on there.
So to do that, I took the shape of the gear and figured that size out, something that would fit down onto the gear so it can hold it on there, and then designed the shaft based off of that with some threads, and then a nut to hold on whatever solution we come up for that part. So, and then you can see if I bring these back, that's the next part we got to build, is something, a circle shaped thing that'll spin around, pick up bubbles, soap in the bottom, and then pull them up in front of the blower.
And so, can you explain how 3D printing works?
Yeah, so there's a filament, and I can show you that.
We can explain that you also make candles and mention his website.
Yeah. Okay. Well,
Pete has stuff on My Maker Co. My Maker Co.
all one word.
All one word. My Maker Co.
QR code. Not ready.
Oh, okay. There's some candles among us, candles being made. Coasters.
Okay, 3D printing works by taking a filament. This is plastic filament. There's different materials. This is polylactic acid, or PLA, and it melts this. There's a nozzle in there that heats it up, and it melts it down to real small, like 0.4 millimeters is the nozzle I used. And then one layer at a time, it draws it out and just puts layer on top of layer. And you end up with your 3D
So,
printed part.
so for the old tech people, that is like the inkjet printers they used to have, and it would shoot ink onto the paper. You're doing the same idea here, except you're using plastic instead of ink. And it can build not only just one layer, but it can build layers up. This is where it sets up and decide there.
Yeah, this is the printer. So these are the three. I have 4 different filaments up there.
How long did it take you to learn how to operate, program and operate this? So talk about you a little bit about your background, where that you got into this.
I started drafting in high school, and using 3D CAD stuff,
Yeah.
which is what you need to do if you're going to make your own things. But I had a cheap 3D printer, so I've always been doing CAD as drawing, 3D drawing as a hobby. And then I got a 3D printer. The first one was a cheap one. Takes a little bit more skill to get things to melt the right temperature, stick to the bed, and work out the way you want it to. This one's a lot easier. You almost plug and play as long as you have the file. You just upload
So
it.
do you think the technology has gotten better as they're developing these, and is computerized stuff helping that, or what's helping develop this better?
Yeah, so computers, smaller, cheaper sensors like LiDAR and accelerometers, all that goes into making this a lot. This machine can sense its own vibration, so it can move even faster and dampen out or like account for that vibration.
Yep.
And then just the more people learn about it, they're able to make it more efficient and more reliable, so that you're not guessing every time you're printing.
So in the future, where do you think 3D printing is going to be?
It's going to be printing a lot of metal and other materials. Whether that goes to production or not, I don't know, because one of the problems is the layer lines. It's not a smooth finish, and then so I can make this prototype, but then if I want to make 15,000 of these because I want to sell at scale or use them at scale, injection molding would be smarter.
Much
It's
faster.
going to be a lot faster. So prototyping is good for some like small use items, or maybe you're going to have less than 100 of them. Maybe 3D printing
So
makes sense.
for the old technology, like the hit and miss engines that I work on, you can't buy those parts, and this kind of technology is actually becoming where you can reproduce a single part and have your engine keep it running.
Yeah, and so you're going to be able to do that with metal.
Yeah, with metals. As a matter of
So that's
fact,
getting cheaper.
I seen where somebody did that. They actually made a water pump, aluminum water pump, on a 3D printer for an old car.
Okay,
Okay.
so go ahead.
All right, so this is the bubble machine that has been assembled now, and we're going to give it a test run.
You can see those 3D parts that I've shown earlier in the video, and this is just a test run container.
Yeah, I don't have. I mean, I still got to build a mount to mount this on, and I got to kind of find a better container. This is a temporary container
Right.
made out of a ocean spray juice bar thing.
Yeah, and a slit cut in it, and then just water and the bubbles mixed up.
I don't know why it's working.
So it's picking up the soap,
Yeah, it's picking up soap.
and now he's just going to test it with using
drill.
a drill, which in place of that will be the engine, but this drill is just going to blow the fan, work the motor that's blowing the fan blower. It's just a test. I'd say it's blowing bubbles.
so it's making bubbles.
Yeah, so what do you gather from that?
Well, I can make it work.
A little faster.
Yeah. Well, I'm running 1,750 RPM.
Okay, is that it?
So we made bubbles. Lots of bubbles.
Okay.
I gotta figure out why this is warping. It might be because of the hot water I put in here. And then I gotta build a better jug, container,
Yeah.
and then gotta make a mount for this. And then a pulley. I gotta get a pulley so that it'll go onto an engine like that over there. One of those engines.
Yep.
And that's what the goal is to run that engine, to turn this pulley, to blow this air, to make bubbles come out.
Okay, we're going to do
And
that
I
at
got
the show
bubbles.
in February.
Hopefully take it to the tractor
Florida.
show in February. We
Okay.
made a lot of bubbles.
All right, thanks.
Yep. Okay, so I made some adjustments because we were piling up a lot of suds right here in the front. I moved it to the outside. I'm going to put it outside now because I got soap all over the floor. And this is running at 1,750 RPM, so I'm probably going to have to go a little faster than that. I can do that with the gear ratio on the other motors. So I'll hook the battery up. And also I found out why it's warping is the water's too hot.
Oh.
So anyway, so this is that, and I take this over.
Oh, much better. Oh, yeah, you got it. Oh, we got a bubble machine.
Of course, they're blowing back in the garage.
Yeah. Oh, that's great.
Actually, 1750 is not too bad if it wasn't blowing back. I think it's
Yeah.
a little more. Maybe bring this closer up here.
Yeah.
And,
Oh, did you block off some of the air?
yeah, I did. I blocked off some of the air
Why is that?
so that had more volume coming up here instead of a wide area.
Okay.
If I went faster, it would do the same thing. But I think I was blowing the bubbles in here, coming out here. So I needed to consolidate it to one area.
Yes.
And
Okay, so great. I'll
yeah,
add this.
so this is closer to what I want. Just like I said, I got to build a bracket. I got to build a tank, and probably maybe a nozzle here that'll come up to one area.
Yeah.
And I got to build a pulley and figure out the ratio to that 5 or 4 inch or whatever I got.
You know,
over there.
Pete could 3D print something that'd snap
he
on
can do
there.
that. Yeah.
Oh, yeah.
He probably do that.
Yeah.
And then it'll work. And
Yeah.
but I got to have a mount, something to hold it in the ground.
Yeah.
Take a picture of that one, take these together. This is a Maytag. Maytag on the right, little jumbo on the left. It could run off either one of those.
Okay. And the Maytag's just a washing machine engine.
Yeah.
You could run it off that?
Mm-hmm. So that would be one of the two. I've got more in it. This is what I'm looking at, trying to run off of.